Hey everyone, it's time to start talking about couples. And couples means two, right? And so what we're going to have here is a system of two forces. And in the case of couples in statics here, those forces are going to be equal and opposite, which means the net force is zero. Because of that, we're going to assume there's no translation. However, there will be rotation taking place. So I can represent a couple with this ring, okay? And I'm going to hold my hands on either side, and I'm going to push up with my right hand, the left side as you're facing it, and pull down with my left hand, the right side as you're facing it. And you can see that the ring will undergo rotation. All right, so there is a rotation. The steering wheel on a car would be very similar in the same effect. There is a rotation, but there's no translation. There's no movement left or right or up or down, if I did it correctly, right? Okay, so there's rotation, but not translation. All right, and so the couple will be the moment that is caused by these two forces, and that's what we're interested in then, is discovering what that moment is. So let's first off, we'll look at the moment, and we'll kind of talk about that point A here for a second. And what I've got here is the ring has some radius, and so there's going to be a radius r there and a radius r there. And so around the point A, I've got r times f, and I've done this on purpose. I've made them at 90 degrees, but we could do cross products. But the moment's going to be r times f. That's going to be clockwise, so that's negative. And then this f over here, which maybe I'm even going to label minus f because it's in the opposite direction, that's also going to create a clockwise rotation. And so the net moment is equal to r cross f, but there's two of them, so I'm going to say plus, well, okay, so this I'm going to call that minus r, and this is plus r because this is left and this is right. And so I'm going to get minus r crossed with f plus r crossed with minus f, because this one is down, right? And so they're the same value, so that's just going to be r, f, and then it's in the clockwise direction, so that's going to be in the k hat direction and negative. But there's two of them, so I'm going to have to bring out a -2. All right, so it would be the diameter, if you will, the distance, the perpendicular distance between these two forces. Or, let me talk about this. I can talk about the line of action for this force and the line of action for this force. And what is that 2r, right? This distance from here to here is 2r, and we'll just call that d. That's the shortest distance between those two parallel lines of action, right? We want to make sure that the lines of action are parallel, otherwise the forces won't cancel out to zero. They don't have to be perpendicular necessarily, in this case they are, but they just have to be parallel on two different lines of action. And so the distance d between them, let me just put the magnitude of the moment is going to be f times d. And this is the perpendicular distance, okay? The perpendicular distance between the lines of action, all right, between parallel lines, okay? Now it turns out, if I do the moment about B up here, right, I'm going to have an R there. Let me just label that R1, vector quantity, right? And then there's R2, vector quantity. And the net moment, as far as B is concerned, the net moment will be equal to R1 crossed with negative F plus R2 crossed with positive F, right? But this is distributive, right? So this is equal to negative R1, because of this minus sign right there, plus R2, parentheses, crossed with the force F. But this is R2 minus R1, but R2 minus R1 is this distance right here, right? The R2 minus R1 is that distance right there. And so that distance is F is D. So the moment is F times D, even though I'm taking it about a different point. The couple, the moment, is the same whether I'm talking about around A or around B. Okay, it's the same value for the moment. And so that's a couple. So a couple is two forces acting on parallel lines of action in opposite directions but equal in magnitude. So the net force is 0, but the net moment is not. And the value of the net moment will be the force times the displacement, or the shortest distance, the perpendicular distance between two parallel lines. Remember, that's the shortest distance also. Go back to your geometry. So the shortest distance between those two parallel lines. And then you just need to figure out, hey, is it clockwise or counterclockwise? All right, and that's what a moment is all about. All right, if you have any questions on that, please leave them in the comments below. Thank you.